Initiating the record. Okay, right. So, hello everyone. I'm really excited to be recording this meeting with our guest, Ian Villan-Vasman, who is an audiologist and the president of the Computational Audiology Network. Today, he will talking about what is computational audiology and why is it important in clinical practice. So, Ian, I really appreciate your presence here, and please feel free to introduce yourself and to begin our discussion.
Thank you, Jennifer. It's great to have this opportunity to discuss with you how we can use computational audiology in clinics around the world, and especially how we could use it in Brazil. We have pre-recorded this meeting, and I'm not sure about the weather in Brazil, but I thought I'd wear a shirt, so it's hopefully that blends in a little bit better. And
Yes.
Feel free to send you questions also after this presentation, and looking forward to, well, how you like it and how your meeting will further progress when you are gathering. So what I wanted to start with is briefly my background. I studied physics and briefly worked in aerospace, but there I discovered that it takes more than 10 years for an idea to get really into a project that works. So I wanted to be a little bit quicker in research and development and innovation, and also see the result of my work, which made me transit into physics applied in hearing, in audiology. So that's where I started in 2011. Around 2020, I started a PhD about the use of AI and teleaudiology in my clinic in Nijmegen, the Radboud Medical Center. And the Radboud, there's several strong research groups around AI, biophysics, but also our ENT department. So that these different groups, we wanted to blend it more or less and see how experts from different fields could collaborate. And that was more or less the inspiration to start the virtual conferences on computational audiology, and also the Computational Audiology Network, which I will later explain. And this talk is a little bit about my personal experience in AI and audiology, but also I like to look a little bit into the future, and then it helps, of course, to read science fiction every once in a while. So let's start with the beginning. What's an algorithm? And you could say that an algorithm, it's just like a recipe. It describes a finite number of steps you have to take to get to an end result. So that could be a nice meal, but it can also be anything you like, in the sense of it could be instructions for a computer to perform, but of course it could also be instructions for others. And this term algorithm, it's derived from a mathematician who lived around 825, who wrote the book of Indian computation, and which was more or less the start of algebra. So that's one thing. We use this word algorithm a lot. So just think about it of a set of steps that are very specific so that you can arrive at goals. And what is AI? Well, I've put here two different distinctions, that all the AI that we have seen in practice so far, that's all weak or narrow AI, which means that it can solve a particular set of problems, like playing chess or recognizing speech, even driving a car. That's all very target driven. But so in the media, you hear a lot about the potential of AI, where they often mean artificial general intelligence, which would be a system that is capable of many different tasks humans can do, and could even maybe replace humans or become more intelligent than humans. And this is all still science fiction. One example would be R2-D2 in Star Wars, or this Her entity in the movie, also in the movie Her. And we don't even know if it's within reach. Some AI visionaries are saying it's a couple of years, others say it's decades. Well, we don't know, and it could be good to be prepared in case we would achieve AGI. But for most of my talk, it will be about this weak, narrow AI. And we could make further distinctions within the field of artificial intelligence, where there's this, it's already started in the 50s with Alan Turing, for example, and most of the AI in that time was all rule-based. So rule-based, it's again like this algorithms, but a little bit more general, and where you try to build in knowledge that could lead to automated procedures. And I put it here also on this slide that was, oh no, I didn't put it was a slide here borrowed from an AI expert, deep learning expert, Bram van Ginneken from the Netherlands, that was all 100% designed by humans. And then around the 80s, it became more machine learning, as we call it, more based on statistics. So there's pattern recognition, and one example is LeNet, one of the first shallow networks, CNN, that was developed for recognizing digits. And these networks became deeper and deeper, and this led to the term, this led to deep learning, where this architecture is maybe designed by humans, but how the system looks like after training, that's more or less this based on the data and a kind of black box of the computer instead of something clearly described by humans. So how does this narrow AI work? Well, here's an example where you have a clear task, which is speech recognition, and where the task for the system is to convert spoken language, like what I'm saying now in English, into English text, or maybe in Brazilian text. And well, then you need to assess how the system is doing. So there's performance metrics, like for instance, the word error rate, the number of words that are transcribed wrongly. And then the system gets the objective, the task, to maximize performance metrics, or in this case, minimize the number of errors. And then you train the network by, for instance, providing audio examples of my voice, but also the transcriptions of what I was actually saying. And then the system can look at all these examples and find patterns in, for instance, my speech or the speech of others that are in the data. And it's even possible to do this unsupervised, that you mask parts of the output and that the system has to figure out what the right answer was. Or the reason to do this is that it's a lot of work to annotate all the data, which is often human work and which is often poorly paid. So if you can automate it, then you can create larger data sets faster. And what the system is doing is this feature extraction that are relevant to predict the right words, you could say. And if you would train the system and you deploy it, you can deploy it on similar tasks. So if it's trained on English speech, can apply it to English speech, but it will not perform at all at, for instance, image recognition or other tasks. A brief history of AI is that many people got impressed about AI when IBM's Deep Blue system defeated chess champion Garry Kasparov. Although this was still a rule-based model, but very strong. And then around 2009, an important milestone was the ImageNet, which was a large database of annotated images, labeled images. And this was like this large training set that these new neural networks could be trained on. And around 2012, AlexNet system won this ImageNet challenge, the challenge to best describe what's on the image recognition. And this was so large of breakthrough that it also led to economically viable applications. Siri, I also put it in here, but that's not the most impressive AI development. Then more recently, I think important for our field is that around 2016, multiple companies claimed that their systems were as good in speech transcription as humans do, but in also a specific setting. So for phone calls, when human transcribers need to transcribe phone calls, they make errors, or like 4 to 5% is their word error rate. And this also happened in these systems. But for instance, if you have a group meeting, many people talking to each other, when it's not really a strict protocol that people are following, then these systems break down, have large problems in understanding what people are saying, while we humans do better. So it depends still on the context. Then in 2017, transformer models were developed by Google. And this was like the foundation for these large language models that many people now have heard about, of course, and that were launched around 2021 with GPT-3. And I think it was in November 2022, ChatGPT, GPT 3.5. So that having said, let's now continue on how to use AI in audiology. And that's, you could say, one of the ways to describe computational audiology, the way of using algorithms and data-driven techniques, modern data collection tools, in order to provide impact to people, to patients. So actionable knowledge or for audiology providers, care providers. We've collected a lot of examples at the website computationalaudiology.com with already the proceedings of 6 conferences or a lot of interesting projects. You can also watch the recordings on YouTube if you want to know more about specific projects. And here I will give a couple of examples of computational audiology and maybe how we could use it in the clinic. So here are a couple of examples of these computational approaches within audiology, where you could say that already in the 50s, there were very detailed models, for instance, about the inner ear and how frequencies are distributed within the inner ear, so the model of tonotopy. Another important thing is fitting algorithms, also decision rules of, or steps you could say you have to take if you know the hearing loss, what kind of gain you will prescribe for certain frequencies, a fitting algorithm. Well, there's examples of big data and machine learning and audiometry, where the Bayesian active learning is a very well-known example by now, but not yet much implemented in clinical care. I will give a further example. And also these deep neural networks are now getting used for describing, for instance, cochlear mechanics or models of human hearing. So, and how could it have impact? Well, for instance, by improving access to hearing healthcare, if people could measure their hearing themselves via automated audiometry or remote care, or by making consumer electronics turn them into hearing aids, right? Which could work when these agents or systems are easy enough for patients to use. And there, I guess, AI may play a role in order to make it easier for people to self-fit, for instance, their hearing aid, or to interpret results, or based on larger collections of data, provide good recommendations. Other examples, this is a nice example from Groningen in the Netherlands, where they use a little bit of human-like robots, or at least robots that people can interact with, children can interact with, to have a kind of playful way of doing audiometry, still done by the patient or person themselves. So it's also a way of automated audiometry. Or here to the right, proof of concept from Manchester, doing the DIN test, the digits in noise test, where normally a digit triplet is played, like 5, 7, 2, and instead of typing it into the keyboard, the patient can just give a verbal response, saying it aloud, and then an automated speech recognition system scores the response, evaluates the answers, and this way you can do the test, which for the digital noise test maybe is not that important to have verbal responses, but you can imagine that if you can do speech audiometry just by talking to the system, not needing a clinician to evaluate the answers, that makes it much more easy to do these tests at home, or let people do these tests by themselves. And here's an example of this quick diagnostics. So what you see here is an algorithm looking for the hearing thresholds. And instead of using the Westlake algorithm, what we do in the clinic, you see it's searching through the frequency and intensity space in a different way, which is much more efficient. What it's doing is it's estimating the hearing threshold, and where it has the highest uncertainty about the threshold, there it presents a stimulus to get a response from the patient and to better know the threshold around those frequencies. So within 20 to 50 stimuli, you can get a very accurate threshold. You can continue measuring, for instance, up to the accuracy you desire. Well, we put it also on the YouTube channel. And there's multiple groups that have developed this. Sorry, let me go to the next slide. Also, an interesting application of AI is lowering communication barriers, using speech to text, for instance, which we may expect in the near future also to be embedded in smart glasses, but at least for virtual meetings, it helps, of course, to have subtitles, but also maybe in difficult settings when you're in a group, for instance, using your phone and the microphone of the phone can help smoothing the conversation or maybe present keywords. And this is a development we expect will further improve, so it can lower communication barriers, or it can be used to score speech audiometry, for instance. Or as what these transformer models can do very well is transforming from one modality to another. So for instance, transforming speech to sign language could lower other barriers. Not sure if this is a video that works. Oh, sorry, no, that doesn't work. And here, example of the Turing game, but then for hearing status. The Turing game is that you're talking to a machine or a person, and you have to guess, was it the machine or was it the person? If the machine can fool you, make you think that it was a person, then it passed the Turing test. And here in this conversation, we were with 4, including Dmitry Konevsky here to the bottom left. He is deaf, and he needed speech recognition in order to follow the conversation. But during this meeting, Nikki Chung-White, who has typical hearing, her AirPods, I think, went down, and she also needed to rely on speech recognition, and it was perfectly fine. So it was nice that it was a level playing field, independent of somebody's hearing status. And here, an additional challenge was that Dimitri has deaf speech, or very typical speech, so that's hard for normal speech to text systems to transcribe it. And this system that we used was specifically trained on his voice, so that instead of 30%, more than 70% of the speech was identified correctly. And here is how you could use these systems in your clinic. For instance, when people present themselves, that they can understand what your colleagues are telling them. And here are some tips how to use it. Make sure that the screen is in between the speaker and the listener, so that people can choose between lip reading or screen reading, for instance. Make sure about the proper positioning of the microphone as near as to the speaker as possible. And maybe if you have multiple speakers, use multiple microphones, but often these systems are more complex and more expensive. And in addition, what helps is often if I see that I'm talking too fast, I see that these systems fail transcribing me well. So then I know I need to speak more calmly. And it helps the system, but it also helps your patient. And lastly, double check that your message has been accurately understood, because sometimes the most offensive words get transcribed while you never said it. Don't want to go into the AI-powered features too much. I mean, I think it's clear to everybody that these kind of features get built into hearing aids and into over-the-counter devices, and that it may add further health applications like step countings or fall detections, which is of course important for the elderly, or maybe allow for heart rate tracking. Another important application is the application of deep learning into noise reduction, where one of the big advantages is that the traditional systems were trained on only few examples of noise. Well, these newer models get trained on larger data sets of noise, so they are better able to really reduce everyday noise instead of these very specific examples that are easier to predict, but are not really what we experience in daily life. And these are also the models that now get built into hearing aids, where it's really a challenge to do so, in the sense that these very large, deep models require a lot of compute, so very strong, powerful computers, but that will not fit into a hearing aid or into an earbud. So then it's the challenge how to reduce the computational complexity by making the deep neural network simpler, reduce the number of nodes, for instance, so that it fits within the hardware of a hearing aid. Another important thing is, as you maybe have experienced with these large language models, you prompt something, you ask a question, and it takes maybe half a minute to respond. Well, for hearing aids, it has to be very fast, within 15 milliseconds. And well, the training and generalization is important. For instance, if it filters out sounds, but it leaves very annoying artifacts, squeaking noises, for instance, then people will probably not be very happy users. Yeah, and how to use it, for instance, with open fittings, where you get the clean signal mixed into the noise that you are experiencing. Another application that I had not thought about 5 years ago, but then I heard about it back in the VCCA 2021, is the group using this in England for training children with bilateral cochlear implants, that they could play games to test where sounds was coming from and to improve their sound localization abilities. Very nice application of virtual training and simulation. And you can use these models. This is an example of an ASR model to simulate human listeners, and then maybe try to tweak and improve settings of your hearing aid or device that you want to improve. This example was maybe revolutionary back in 2023. Well, but now we all have probably have experience with using systems, these chatbots like ChatGPT, for all kinds of questions and writing text. It can pass medical exams, so there is somehow knowledge stored in these fast models. And back in 2023, together with Duet Swanepoel and Vinay Manchaya, we wrote an article in the Hearing Journal about how, for instance, patients could use this for initial screening, for instance, already by asking questions to as chatbot that you experience hearing difficulties, or no, not even hearing difficulties, but difficulties to follow conversations. Then the chatbot may maybe suggest, well, it could be due to hearing loss, and you may need to schedule an appointment with the audiologist. And probably, that's at least now my experience, people also ask questions to these bots. So they get educated and supported by these chatbots, but it also means we get different questions as audiologists. And we need to, well, be careful that we don't rely too much on these chatbots, especially when they are black boxes. And for teleaudiology services, it helps that if it's asynchronous audiology where people have to do something by themselves, a test or something else, it helps if there is a friendly agent that can counsel them, help them through the procedure, and maybe even solve technical issues, for instance. So in the remainder of this talk, I want to go into the risks of into the risk of artificial intelligence. And in the media, there's a lot of attention for this existential threat of artificial general intelligence, which it's good if there's experts dealing with this, but that's not something that we as audiologists need to deal with. There's, however, one problem with this risk of artificial general intelligence, that it steals a lot of thunder from the actual real threats already occurring now, that people get discriminated by algorithms due to their skin color or to their postal code where they're living, because these systems think, oh, this person is at a high risk not to be able to pay the bill, so we don't let this person open an account. And that's, I think, something very real risk, which is seeping into society already at large, and which may also cause problems in audiology. So in hearing healthcare, these biases in data are very important risk for us to consider to better understand the recommendations of these systems. For instance, if a system gives a recommendation, is it truly trained on your population? Does it really make sense for Brazilian patients, for instance? Another thing is violation of privacy. If you see, for instance, these large language models that have scraped everything on internet, not maybe respecting the laws of privacy or laws of authorship, well, there is the risk of re-identification, and people may have problems of not having access to the data where the system has been trained on, or control over their data. That it's nice if people could test their hearing, but if then it's not possible to share the results with a clinician, that makes it harder for the clinician, of course, to do their work and also to do it responsibly. And this control over data may be very important in the future. Another risk is this unauthorized or undesirable use. Privacy invasion is, of course, already clear. Using it for tracking, the speech recognition systems are, of course, ideal for governments that like to listen to what their population is doing. So for monitoring, for a police state, it's also the perfect system. So there's a lot of dual use. And something I think important for clinicians is this responsibility for errors, that maybe if you are using a chatbot, you can, as an expert, filter out the nonsense responses and correct it. But will your patients also be able to do so? And will you feel responsible if a patient of you is using a chatbot that you have recommended and then it goes wrong? So there it will be important to have oversight and regulation to help you as a clinician. And it may also be important as group of clinicians, maybe as a society, to collaborate and to share best practices and lessons to prevent your colleagues from making the same mistakes. And lastly, also to be open about your mistakes. I mean, this is new for many people, so there will be mistakes, and it's, I guess, important to be transparent about these errors and mistakes so that we can learn from it. Well, I think some of the things to go forward is try to go for open exchange of data. And here's an example that people maybe in the future will measure their hearing, only have mild hearing loss, so they don't go to the clinic, but buy some OTC device. When their hearing deteriorates in 10 years time, it would be nice to have these measurements and be able to import it in the database of your clinic to make better predictions of this patient's future hearing status. So using fair databases that are findable, accessible, but also interoperable, so that it doesn't depend on the vendor, on the brand you're using, on the type of audiometer you're using in your clinic. You also want to be able to import data from other clinics so that you can collaborate, or from other types of care providers, or for example, the patient themselves, and make it reusable for further analysis. And this is another recommendation, which would be go for local small language models instead of these large language models, because these large language models, they require a lot of compute, a large carbon footprint. They're very expensive, so that only the very big companies like OpenAI and Google can afford it, while they are maybe blind to certain cultural sensitive topics. So if you would train it specifically on Portuguese, Brazilian dialects and terminology used by audiologists, you can ensure more accurate transcription and also much better responses. And you can make it comply to your law for data privacy compliance, also the quality procedures you maybe as Brazilian audiologist describe. Well, the cost-effective compute could mean that you could maybe run it locally, not on a supercomputer, but on a couple of local computers, maybe still a network, but a network that can be run by a university or maybe by a clinic. Fast iteration and customization, and that you control it, reduce bias, especially the weird bias, the Western educated, industrialized, rich, democratic, because a lot of the data where these large language models are trained on are from, well, Western societies. And what's interesting that with colleagues from Brazil, with Hector Corella de Matos, Thais Morata, and also others, we worked on how can we use these large language models in terms of making health information more readable, accessible by layman people. And one of the ways to do so is to restrict these large language models to verified sources. This is called, this is a retrieval technique, RAGs, where we thought that way we can make the systems more accurate. But by doing this, it leads to inconsistent readability. So grounding this very large language model may deteriorate the readability. It's also very ineffective that you have a large model and then need to constrain it, and also hard to audit because different systems will need to be constrained in different ways. It's hard to make comparisons. So I think, again, a case for develop these systems locally together with experts and make sure that it complies to your local needs. So I'd like to end with a couple of recommendations. So AI and automation can assist clinicians and patients, but it will not do so automatically. It can do so by design, and that means that you as clinicians need to be included in this design process early on. I think open standards will help us, and then I mean the rest of the world, in developing good systems where we can exchange data, where we can compare products, where we have real competition for quality instead of only for power. Interoperability will help us there so that as clinician, you can choose between multiple platforms, patients can choose, and it will help collaboration within countries and hopefully also between countries. I hope you will consider some of these risks of big data and AI technology and, well, experiment local and hopefully create better and more accessible hearing healthcare this way. So here's one website or part of the website where we try to collect models and tools that could be useful for colleagues to share. And if you're interested, you can join the Computational Audiology Network. It's free for students and members of the International Society of Audiology. We are an informal and strong network, but actually also becoming a little bit more formal in the sense that we have a foundation now, which hopefully in the future can run projects. We have a nice team from all over the world, and we hope to share knowledge about the use of AI and also help to influence better design, better for patients and clinicians in the future. And lastly, this summer in June, 25 and 26 in June, this Spanish team led by Joaquin, Maria, and Miriam are organizing the next PCCA, where the first day will be about understanding hearing and the second day about clinical impact, how to use AI in the clinic. So similar to what I've talked about now. And another thing that could be interesting is that before this conference, we will organize also workshops about how to use machine learning in audiology or in computational modeling. All these activities are for free, so it's simple to register, and we hope to see you virtually in Spain later this year. Well, thank you for your attention, and let me know if there are questions.
Okay, thank you, Ian. So I have some questions. As you was presenting, I thought some things, but I will just start and maybe.
Would you like me to also share the screen, or shall I stop sharing the screen?
You can stop. You can stop.
Okay.
I think it's better. Yeah.
Let me stop. Let me figure out how to. Oh.
Yes. Yes. Yep. Thank you. So I will do some questions here, but if someone wants the audience to make some questions, they can write an email and we will answer them. So I will bring about a little contest here in Brazil, and you can share with me the contest in your country, in Netherlands. But sometimes I think we have some challenge with our professional because we think we are just audiologists, and so we don't have to think about the engineer that is happening here. So I think people get the stop in this area. So I will just do the procedure and I don't have to think more about that. But that is one thing. So we divide like, this is a work of the electric engineer or a computational engineer. So that's one problem. And another problem, I think it's the data. So I will talk about my research a little bit. So you are trying to predict some things in the potentials, the located potentials. And we have a big problem with the data because it's a small data. And we are trying to use machine learn. And now we discovered that it's better to use deep learning, but we need a big data and we don't have that. So I want you to explain how it works in your place, this problem with the data.
Okay, well, let me start with that. In the Netherlands, we don't use teleaudiology so much, and it's also because there's small distances. And with the use of AI, also there it's limited because, well, we've a lot of clinicians, so that provides a high bar that you have to be better than the clinician before people will use this AI system. So the use of AI in health is more in, for instance, radiology, in image recognition. And I expect that in the next years, there will be more and more use, but we'll have the same problems as what you're describing. That means you not only need an audiologist, but you also need a data expert, and you need maybe a privacy officer on board and different engineers. So in terms of having a holistic view, then you can think about, okay, but how to improve your hearing healthcare services within your region. Then you want to include this all, how to make it affordable, have cheaper solutions, but also still be able to understand what's happening in your region. For instance, by knowing if people do hearing screening, how many of those people get referred to clinics, and have this kind of information. So I think this is a large challenge, which means there's a lot of things to do. And that could also mean that we as audiologists should be less afraid that some of our tasks will disappear and get automated, but make sure that these new tasks that you have a say. So that's one part of the answer. And what was the question about using deep neural networks? Well, it's really difficult and expensive to create a good data set. So there's examples that, for instance, big American companies paid, in some countries, schools to let children do tests while having these EEG systems on their head, collecting their data on a way they could never do in the US because it's not ethical, but it was no problem to do this in other countries where there's no oversight, etc. But this way, you could collect data about maybe also the problem you are trying to solve. You have this general data set, and then you can add your specific patient group and maybe find patterns better because you already have a pre-trained model. Well, I expect that it's just very expensive to do it well. And you have to really think about how can you have a large impact so that you can justify the resources you need to improve your model. So if it's only making it 1% better, maybe it will be very hard to achieve this, or you need to collaborate. And then again comes in this fair databases, that if you maybe make a tiny collection of 10 to 20 patients, but I could also add 10 patients from my clinic and somebody from a German clinic and from 20 other clinics, then you can also get a large set of data, with the advantage of not needing these very large corporations to collect the data in ethically unsound procedures. So open source and open science, I'd say, would be the way forward, and it's really in our best interest.
I agree with you. I think we should all work together, and I think this will get better for everybody. So, but thinking about what we are talking about now, so there are some young researchers and students that will assist us. So, what is your advice for someone that is beginning in this area? So, one skill that they should develop. So, what is your advice?
Hard question, because well, I expect that our work will change, but also that society will change anyway. So it's good to be open for trying new things. Try to work at different locations if possible. For instance, if you have got training in one university or city, try to work at a different institution to see the differences, because some of these differences will be important and other differences will not be important. So then you learn what does matter and what doesn't matter. Try to get experience maybe abroad. It's nice to work in research, but it's also poorly funded and often with low security for jobs. Yeah, so it really depends, of course, on your personal situation, and it would be nice if clinics can offer you decent wages and a good contract so that you can develop yourself, knowing that skills you use you learn can be used within the setting you want to use them. But I'm not sure. I don't know how the job prospects are in Brazil.
Mm-hmm. I think it's will get better, and more and more we are talking more and more about that. But I think we are just starting. But I
Mm-hmm.
think maybe this thought that we are just audiologists and this is a work for an engineer or something like
Yeah,
that. Maybe this is a big challenge, and we have to break this in your head. So I think it's
yeah,
a first step.
yeah. And then it may help to put the interest of your patients first. That if you show why you are doing meaningful work as an audiologist, you get more support from your patients, and they can also understand that maybe some of these tasks do not need to be automated versus others that it will help. And then together, there's a lot of common interest, I think, both for patients as clinicians. So that may also help and make your work more meaningful.
Yeah, and I think we had more idea where is the IA and the I the I.
Mhm.
I thought I speak in Portuguese. Sorry. Like when we put hearing aids in patients, there is something happening there, like the use of AI. So if we know more about that, we know how to use and how to get things better to our patients.
Yeah, and then it's a problem that a lot of these manufacturers, they share only marketing information, how to sell more hearing aids, but not clearly the details how these hearing aids work. And then you
Yes.
cannot, if patients have questions for you, how does this hearing aid does this, and what are the limitations? Well, it's hard to inform them if you don't have the information yourself. So there it helps, of course, to have transparency and good training also, sometimes by manufacturers or by other experts.
Yes, yes. But if you want to say something else,
uh, well, I hope there will be interesting discussions at your meeting, and looking forward to maybe meet some of researchers from Brazil at the World Congress of Audiology in Seoul, and well, looking forward also to maybe submissions from researchers to the VCCA and continue the conversation over there.
yes, we can put in our Instagram the site of VVCA. I think
Yes,
it
please do so.
works. Yeah.
We have had some great contributions, also cool short videos from Brazilian teams, and so it would be nice if we get more of these great submissions.
Yes.